Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous lecture, that is motion of an object along a straight line. In that lecture we show the concept, or you can say definition of distance, displacement, speed, average speed, velocity and average velocity, and we also show some numerical problem based on these quantities in that lecture. Okay guys, now in today's lecture we will learn uniform and non-uniform motion of an object. Then we see what does mean by acceleration or deceleration of an object. Then we derive equations of motion of an object by graphical method. After learning all these things, we will also see some numerical problem based on acceleration, velocity and distance. Okay, so guys, now here time to see definition of uniform motion. Okay, when an object traveled equal distance in equal interval of time, then motion of an object is called uniform motion. Okay, so what does mean by this one? See, a particle is moving on a straight line. Suppose it starts moving at a point A, and after t equal to 3 seconds it goes to point B and covers distance 12 meter. Okay, and B to C here again 3 seconds, or this one 12 meter, or again C to D in 3 seconds. So this is also 12 meter. So what you see here, a speed equal to distance covered by the particle 12 and the time elapsed is 3, so it will give you the speed which is 4 meter per second. Okay, the next one B to C also 12 by 3, so this is also coming guys 4 meter per second, or again in interval C to D. Okay, speed is guys here distance 12 or time elapsed 3 seconds, this is 4 meter per second. So what you see, in equal time it travel equal distance, so such type of motion of an object is called uniform motion. Okay, so second one is a non uniform motion. Okay, so when an object travels unequal distance in equal time interval, or unequal time equal distance, then such type of motion is called non-uniform motion of particle, or you can say object. Okay guys, bus, truck, aeroplane, etc. all are denoted in physics by particle or object. Okay, now suppose in this case here, suppose here the particle start moving P to Q in 3 seconds. Suppose this is 14 meter, or again in 3 seconds, suppose it covers 16 meter. Okay, and again this one R to S, again in 3 seconds, suppose this is 24 meter. Okay, so what you see in P to Q speed is guys here 14 by 3. So this one will come guys 4.666 meter per second. Okay, or in this case speed B to Q to R equal to 16 by 3. So this is 5.333 meter per second, or this one speed here R to S equal to 24 by 3 equal to 8 meter per second. So what you see in different time interval, speed is different. So we can say the motion of the object is non-uniform motion. Okay, now guys, next we see acceleration. Okay, acceleration, the rate of change of velocity per unit time is called acceleration. Okay, so guys, a velocity has a direction with magnitude. We learned in previous lecture. The link of that lecture is given in description box. Okay, so acceleration has also direction. Okay, when object is accelerating, then velocity or speed increases with time. When object is decelerating, then velocity is decreasing. Okay, so in this case direction of acceleration is opposite to motion of an object. Okay, so guys, the first one, see here definition. If the v is a velocity after time t, okay, velocity, or you can say after time t, okay, or u is initial velocity. Okay, so you can say acceleration v is a velocity after time t minus u initial velocity or time lapse during change of velocity u to v. Okay, so you can write it as a vf minus vi initial or time elapsed to change this velocity will give you acceleration. Okay guys, when a is positive sign, then v or a is in same direction. Okay, or when a and v, suppose this one has a opposite, okay, direction. Okay, so here a is negative. Okay, here guys you can say, sir, you are putting a arrowhead on a, it means it indicates a vector quantity. Okay, you will read in higher classes. Okay, so see one question based on this one. Okay, question: a car change its velocity say 4 meter per second to 16 meter per second in time interval 4 second. Okay, so find acceleration. Okay, so guys we can use here formula a equal to v final velocity minus initial velocity or divided by t. Okay, so you can write here 16 minus 4 divided by 4, or this one guys 12 by 4. Okay, or this is meter per second or this is second, so you can write 3 meter per second square. Okay, so what you here notice, the unit of acceleration is meter per second square, or in some books you see it is written like this, ms or to power of -2. Okay, so both are same. So guys, now next we see how to represent motion of an object on graph, or you can say velocity time graph. Okay, or what you get information by this one. Okay, suppose an object velocity is v, or this is t in second. Okay, or this is also meter per second. Okay, now suppose at t equal to 0 the object velocity is 4, then after elapse of time 2 second it is 8, then again 4 second this is 12, or 6 second then this is 16. So what you see here, in equal interval of time its velocity changes equal. Okay, so such type of motion of particle is called uniform acceleration of motion. Okay, so see what is it's the graphical representation and what information you will get. Okay, here this one is a time axis, or you know it is in mathematics x-axis, or this is velocity axis, or this is meter per second. Okay, now this one is 0, this is 2, this is 4, or this one 6. Okay, or now see, this is 4, 8, 12, or here 16. Okay, so what you see guys, here t equal to 0, the velocity is 4, t equal to 2, then it is 8, then this one is 12, or this one is guys 16. Okay, if we join all the points, then it becomes a straight line. Okay, so what you see, if this value you will calculate, then what you here find, tan theta equal to the vertical distance here 16 minus 12, or this one guys, the horizontal distance between these 2 points equal to 6 minus 4. Okay, so what you get, 4 by 2, or you can say this is 2. Okay, so guys, when the motion of a particle is given velocity time graph, then this tan theta, or you can say gradient, is known as acceleration. Okay, so this is 2 meter per second square. Okay, so you can say, sir, when tan theta is more, then acceleration is more. Okay, or you can also conclude by this graph that the motion of the particle is not starting from rest, because at t equal to 0, see, it is not passing through origin. Okay, if it passing through origin, then here t equal to 0, v equal to 0, then the object must be in rest. Okay, so in such way you can analyze the graph. Okay, now guys, here you can apply this formula, v equal to u plus at, when a is constant. Okay, now here if we calculate here value of a in each interval, then what you see here, 0 to 2 second. Okay, so acceleration will be 8 minus 4, or divided by 2 minus 0, or this is coming 2 meter per second square. Okay, again this one, 2 to 4 second, acceleration equal to 12, final velocity initially 8, or time elapsed equal to again 4 minus 2. So this one guys, 2 meter per second square. Okay, the next one guys, if we say 4 to 6 second, acceleration of the particle will be 16 minus 12, or 6 minus 4, so this is 4 by 2, so this is 2 meter per second. So what you see here, acceleration is constant. Okay, when acceleration is constant, then this line must be straight. Okay, and one information you can also take this here, by using this formula you can calculate the velocity. Okay, suppose here you don't know the change of velocity. Okay, just you know acceleration of particle is 2 meter per second square, or its initial velocity is 4 at t equal to 0. So what will be velocity at t equal to 6 second? Okay, so just you can apply the v equal to u plus at. Okay, so u here 4, then a acceleration 2, or what time lapse is 6 second. So you can write 4 plus 12, this is 16 meter per second square. Okay, So in such way guys, you can use this formula V equal to U plus AT, where A is constant or A is uniform. Okay, now guys, next we see the how to find a distance by velocity time graph. Okay, so distance by velocity time graph. Okay, suppose this one is a time axis here, time second, or this one is velocity. Okay, so this one is meter per second. Okay, now suppose the motion of the object is constant, or say this is u. Okay, so if the particle motion is constant at t1 time and t2 time, then what you see here, the distance covered by object from T1 to T2 equal to here speed into time elapsed. Okay, so you can say, sir, this is u is constant or this is T2 minus T1. Okay, of if T2 minus T1 equal to T, so this is ut. Okay, so what you conclude here guys, area under this one u and time will give you the distance covered by that object in time t. Okay, so now next you see other equation of motion here, equations of motion by graphical method. The first one is guys position and time relationship. Okay, suppose this one time axis or this one velocity axis, or suppose the particle is moving at a start with u and after time t its velocity becomes here v. Okay, so now area under this curve OA BC will give you distance covered by the particle in time t. Okay, so you can say if S is the area under this one, okay, graph, so it is basically area of trapezium. Okay, OA BC. Okay, or you can also say, sir, we can also make a right angle here, say this point is here D. Okay, so you can divide this one, area of a rectangle OADC plus area of right angle CD or B. So this one guys, you can write here OC into OA plus 1 by 2 base CD or height BD. So you can further write U into T plus 1 by 2, or here guys CD, it is T or BD. So difference between these two equal to v minus u. Okay. So further you can write s. Okay. Now guys, as you know, v equal to u plus at. Okay. So if you substitute this value here, v here, so what you will get? Okay. So ut plus 1 by 2 or t, or this is u plus at minus u. So u cancel out. So finally you can write, sir, this is ut plus 1 by 2 half at square. Okay. So such relationship between distance and time is known as position and time relationship. Okay. Now the next guys, here we see position and velocity relationship. Okay. So what does mean by this one? If S is this area under this graph, okay, so this one is equal to area of trapezium guys, OA, B and C. Okay, so you know the area of trapezium equal to 1 by 2 into sum of the side length of parallel lines, here OC plus AB into height, which is OA here. Okay, so you can further write 1 by 2 u plus v, or OA equal to guys here t. Okay, now guys, as you know, v equal to u plus at, so we can here write t equal to b minus u by a. Okay, so further you can write 1 by 2 b plus u or b minus u by a. Okay, or further if you simplify this one, so this one come guys, v square equal to u square plus 2as. Okay, so guys, now we learn equation of motion of an object. Okay, so now guys, next we see how to apply these equations of motion for solving the problem. Okay, we learn three equations here. V equal to u plus at, the second one is s equal to ut plus 1 by 2 at square, or the third one v square equal to u square plus 2as. Okay guys, one more thing, you know, in examination, suppose this one. Okay, so what you see here, if the particle is moving with some acceleration, time t is this v and this one u. Okay, or this is velocity axis meter per second. Okay, or this is in second. Okay, so what you see, this one will give you v minus u, or u divided by the base time t equal to a. So a is what here? Theta. So theta is a gradient. Okay, so when in examination, suppose this one is guys tan theta equal to v minus u by t. So in examination, like slope is given like this one or this one. Okay, so what you see here, if you further this one increases like this one or this one, so what you see, this angle is more comparison to this one. Okay, so you can say, sir, this acceleration is more comparison to this one. Why? Because tan theta is greater. In this case, with respect to this one. Okay, one more equation left out, which is average velocity. Okay, this one equal to net displacement, okay, divided by time elapsed. Okay, so what will come here in this case? Ut plus half at square is a net displacement, time elapsed t, so you can write it as a u plus 1 by 2 or at. Okay, or you know v equal to u plus at or a equal to v minus u by t. So substitute this one, u plus 1 by 2 v minus u by t, or this is multiplied by t, t cancel out, so this one becomes 2u plus v minus u by 2. So finally you can say v plus u by 2 you will give you the average velocity of an object. Okay, now see question on average velocity. A question: calculate average velocity of motor cycle when its initial velocity is 40 meter per second and final velocity is 80 meter per second. Okay, so solution here: average velocity equal to, guys, what? V plus u by 2. Okay, so v is here final velocity or I is initial velocity, so 80 plus 40 or divided by 2, so this is 120 by 2 or this is 60 meter per second. Okay guys, if you write unit in each step, so it is very easy to know final unit. Okay, now see one challenging question. Okay, suppose here an object, okay, moves A to B towards north 6 meter in time say 3 seconds. Okay, and moves B to C towards east 8 meter in time 7 seconds. Okay, so find its average speed and average velocity. Okay, so solution here. So initially see the particle is at point A, now it start moving in north direction 6 meter, so it reaches here in 3 seconds. Okay, again the direction of motion of object changes or it is moving towards east. Okay, 8 meter in 7 seconds. Okay, so what you know for the average speed equal to total distance covered by particle by total time elapsed. Okay, so what you write in this case here, total distance. Okay, so first it is 6 meter, then again here 8 meter, or the time elapsed 7 second plus 3 second. Okay, so you can write 14 by 10 meter, or this is second, this is 1.4 meter per second. Okay, and what about guys average velocity? Okay, so average velocity does not depends upon the how the route followed by the particle. Okay, we learned in our previous lecture, the link is given in description box. Okay, so in this case net displacement divided by time elapsed. Okay, so what you get in this one, net displacement means initial position to final position joining by a straight line. Okay, so this one becomes 6 square plus here 8 square or under root, because this is one is a hypotenuse of a right angle triangle. Okay, so you can say this is coming sir 10 meter. Okay, so you can write here 10 meter divided by total time elapsed 7 plus 3 10 second. Okay, so this is 1 meter per second. Okay, so see how the average speed and average velocity differ when the direction of motion of an object changes. Okay, now guys see some problem based on acceleration and distance. A question, a car is moving with the uniform acceleration and changes its speed from 9 kilometer per hour to 36 kilometer per hour in 5 seconds. Find the acceleration of car and distance covered by car in 10 seconds. Okay guys, so solution here guys, what information is given here, first we see. Okay, so initial speed is 9 kilometer per hour. Okay, and after time t equal to 5 second, its speed equal to 36 kilometer per hour. Okay, then what shall be its acceleration? Okay guys, for solving such type of problem, first of all what we do, we convert the here speed in meter per second. Okay, so here u equal to 9 kilometer per hour. Okay, so we can write it as a 1000 meter divided by 3600 second. Okay, so this one 1 or this one guys 400 s. Okay, now this is 1 again, or this is 2.5. so you can say sir the initial speed of car is this one. Okay, again v equal to 36 kilometer per hour. Okay, So we convert the same into meter per second. Okay, so this becomes guys 1, or this is 100 or second, or this one is meter. Okay, so this becomes 10. Okay, so this is 10 meter per second. Okay, we know v equal to u plus at. Okay, here the v is 36 kilometer after time elapse of 5 seconds. So we can write it as a 10 meter per second. Then again you can write here initial speed 2.5 meter per second, or this one a, or time elapse is 5 seconds. Okay guys, one thing you notice, I am writing the unit. Okay, why? Because if you write the unit, then you can not make a mistake to finding the final unit. Okay, so this is becomes 7.5, or this is becomes 5, or this is meter per second, or this is second. Okay, so finally you can say, sir, the acceleration of the car after 5 seconds is this one. Okay guys, so what we derived equations of motion, v equal to u plus at and s equal to ut plus half at square, and then v square equal to u square plus 2as. Okay guys, which formula you will use? Okay guys, here we will use this formula. Okay, why? See, here first we write s equal to this is 2.5 into 10 plus 1 by 2, or 1.5 into 10 square. Okay, when you solve this one, this is 25, or this one guys becomes 75, then you will get 100 meter. Okay guys, if you will use this formula, then what guys make a mistake, they will write this one. Okay, v equal to here 10 square, then u equal to 2.5 whole square plus 2 into 1.5 or into s. So what you will get? You will get 100 minus 6.25 or divided by 3. So s will come guys here, this one 93.75, or this is 3, finally it will come 31.25. Okay, so what mistake we did for solving the formula, this one. Okay guys, we here made a mistake. As you know, the v is a velocity when the particle achieved after elapse of time. Okay, here this one is given after 5 seconds. Okay, so if you want to use this formula, then first of all what you will do, you have to find the final velocity of the particle at t equal to 10 seconds. Okay, so this one becomes guys 2.5 plus, you know the acceleration is 1.5, again you can write here t equal to 10, so you will get 2.5 plus here 15, or this is 17.5 meter per second. Okay, then you utilize this formula, then you will get the answer. Okay, this whole square u equal to here guys 2.5 whole square plus 2 into a 1.5 then s. Finally what you will get guys here, this will come 300 divided by 3. Okay, again you will get 100 meter. Okay, so you must remember these things here. The value of v, that is final velocity after the time lapse. Okay, so this question is tricky because the velocity is telling after time elapse of 5 seconds. Okay, but question is asking a distance elapse of 10 seconds. Okay, so finally we conclude that guys, when you solve such type of problem, so you must see at what time the final velocity reached. Okay, so here the 5 second is given or 10 second is given. Okay, as object is accelerating, or you can say car is accelerating, then t equal to 10 second, its speed equal to this one. So guys, we can not just use final velocity this one. Okay guys, so in exam if you want to take less time, so you use this formula for solving such type of problem. Okay, because see here final velocity is not coming in this equation. Here initial velocity or speed is only coming, acceleration is coming, or t is coming. Okay, so hope the solution of this question is now clear to you. Okay, now see the next question. Question is here, a student driving a bicycle at velocity of 10 meter per second. Okay, and suddenly he applies brake, and after traveling a distance of 8 centimeter, the bicycle stops. Question is here, find the deceleration or retardation of bicycle. Okay, so solution guys here, first of all we see which informations are given in a question. Okay, so initial information is given u, initial velocity equal to 10 meter per second. Okay, and the second information you can say the final velocity of the bicycle is 0. Okay, so this is 0 meter per second. Okay, and what distance it covers to come a stop, so you can say sir s equal to 8 centimeter. Okay, so guys we read three equations of motion. Okay, so which equation you will use for solving such type of problem. So we will ignore these two formula. Why? Because it depends upon time, or in our question time is not given. Okay, so we will use this one. Okay, so guys, could we write this one? See, so my answer is no. Why? Because guys, here see, here distance is given in centimeter, so it must in meter. Okay, so we divide it by 100. Okay, so this becomes in 8 by 100 meter. Okay, so now we can put the value what we have. Okay, so final velocity is 0 square, then initial 10 square, okay, plus 2 into a. Now s equal to here 8 by 100. Okay, so next we can write this one, or you can say, sir, this is 1 or this is 50. Again, sir, this is 4 or this is 25, or this is 1 or this is 6.25. Okay, so you can say, sir, we can write acceleration a divided by 6.25. Okay, so next we can write this one. Okay, or a equal to minus 100 into 6.25. So this will come 625 here meter per second square. Okay guys, here negative sign indicates that acceleration is opposite to the motion of the car, so that's why it is coming negative. Okay, so guys, finally you can say deceleration of car equal to 625 meter per second square. Okay, we here omitted negative sign. Okay, because we use here word deceleration of car. Okay, so the final answer of this question is the deceleration or retardation of bicycle is 625 meter per second square. Okay, so hope guys, now the concept of motion of an object along a straight line is clear to you. Guys, if you think this lecture is informative for you and for others, so please like and subscribe and share to your friends and family. Okay guys, one more request from you. If you want to be updated for my next lecture, so please on your YouTube notification. Okay, so thank you once again for listening and watching this lecture.